Okay, Bismillahirrahmanirrahim. Good afternoon. So now we are in the chapter numerical integration. So I really hope that you are ready to study. Everyone can hear me, tak ada masalah dari segi pendengaran. Maksud saya sistem audio ni lah. Okay. So as an introduction, integration can be defined as anti-differentiation. Okay, so previously we study about the differentiation and now is the actually reverse back, okay, ataupun anti-differentiation. Okay, there are a lot of wide application. Okay, you can use for measure the area of find the area, the volume below a curve or bounded by a several curve. Okay, for example, if we have the acceleration, so we can integrate we can use integration to find the velocity and also the distance. Okay. Okay. So numerical integration normally there are several methods. Okay, we have trapezoidal rules, Simpson 1/3 and also 3/8. Okay, 3/8, and also the Gauss quadrature. Okay, yeah, what we are study nowadays currently actually numerical by numerical integration. So which mean that we integrate based on the data. Okay, so we have a data x and y, and then we try to use a equation to integrate it, okay, to find the value of integration. Okay, because normally the other methods we have an equation. Okay, for example, y equal to x power of 2, and then we can easily to integrate. Okay, so by the equation. Okay, now it's not by the equation, now by the numerical, by the numbers. Okay, as we know that trapezoidal, I believe everyone still remember the shape of trapezoidal. Okay, ataupun they call it as a trapezoid. Ni kenapa ni? Wait Okay. Okay, so for example, this is a graph. Okay, this is the graph. The graph name it as a fx, or the fx of a function. Okay, this is the graph, and then we want to integrate, where the integration is the area below the graph. Okay. So it's bounded between A and B. Okay, they have an interval between A and B. Okay. At first approximation, kita punya integration from A to B fx dx can be approximated by an area of the trapezoid. Okay. For example, if you have only one segment, okay. So kita tahu trapezoidal dia punya bentuk macam ni lah. Okay, trapezoid macam ni. So dia ada tinggi kali lebar darab 2 kan. Okay, so dia ada tinggi sini darab sini bagi 2. Macam tu. Siapa ingat lagi trapezoidal punya formula? Who remember the trapezoidal formula? Ada yang ingat? Macam ni nak cari ni? Tinggi kali lebar bagi 2 For example, this is x, this is y.
Tinggi tambah bagi 2.
Apa?
Tinggi tambah rendah.
Tinggi tambah rendah. Oh, ni tinggi
kali lebar bagi 2.
Tinggi tambah rendah Ni kata y1.
Kalau tak silap saya lah yang tu.
y2, so y1 tambah y2, and then
Darab lebar bagi 2.
darab x divided by 2. Okay, this is area under the graph lah. Okay, so kalau kita tengok kat sini memang macam tu lah. Okay, ni y1, y2, and then this is x and divided by 2 lah. Okay, however I try to show you, for example, this is the area, and we use the concept of trapezoidal for the whole segment. So kita tegakkan macam ni. Okay, so do you think they will get the correct answer, or the, I don't know, is it they will get the correct answer? Agak-agak betul tak jawapan dia kalau kita buat macam ni? Compare dengan yang sebenar lah, compare yang sebenar. So kalau kita compare yang sebenar, memang confirm akan lari lah. Okay, we won't get the correct answer. Okay, so we will get a big error. Okay, if we compare the calculation and also the real area. Okay, this one will get the higher error. Higher error. Okay, so that's why for a better accuracy, so in the interval of AB, between A and B, is divided into n segment. Okay, with equal length. Okay, I try to padam dulu. Okay, for better accuracy, we try to divide into several segments. Okay, for example, katakan nak buat 10 kan, so we will have 10 segments. So this one segment, and then this one another segment, and then another segment, and then another segment, another segment. Okay, so from here we can see that the more the segment, the more accurate lah. Okay, so siapa tak tahu, I don't know how much I draw the segment. Okay, the most important the length between the segment is must be equal. Okay, so that we can use the same equation. Okay, so at this point lower error lah. Okay, error will be very low. Okay, so XO will be the same as A. So this one become XO and this one become XN. Okay, it's equal to B. Okay, so nanti akan ada X1, X2, X3, X5, okay, until Xn. Okay, so the value of fx is computed as so actually this one we need to measure. Okay, for example, if they give you equation, okay, for example y equal to x square. So kalau they ask you, they give you equation, and then they want you to do a integration, numerical integration. So what you need to do, you need to enter the value of x. Okay, masukkan nilai x, and then you dapat nilai y ataupun fx. Okay, or fx. So saya pun dah terbiasa kan dengan y, so mungkin dengan zaman belajar dulu fx y. Okay, so fx, okay, dapat fx, so we will have both x and fx. Okay, fx and also x, then we can do a calculation. Okay, and also we can do a comparison. Okay, as I draw before, so we have a lot of segments. Okay, so this is the general integration equation. Okay, we start from A until N. Okay, and then since we use several segments or N segments, and then we will have several value of area. Okay, So area 1, area 2 until area n. Okay, so area, for example, the area 1, area 2, area 3, blah 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 until area n. Okay, so we sum up together, then we will get the total area, so the integration value. However, if we calculate each area one by one, so it will become so many. Okay, a lot of area we need to calculate. Okay, and will be more complex, and mistake might be happen. Okay, mistake might be happen. Okay, and then they try to simplify. Okay, they try to simplify. Okay, setiap area, each area trapezoidal area. Okay, this is the formula. Okay, for each segment, and then they try to simplify. If you can see from here, each segment consists of the current and also the next. Okay, for example, 0 and 1, 0 is current, next is 1, easiest to understand. Okay, untuk memudahkan saya cakap 0 is current, ini next. So sama dengan ini yang seterusnya adalah current dan juga next. So kita tengok kat sini F1 dan juga F1 ada di kedua-duanya. Okey, di sebelum dan juga selepas, sama juga yang F2 dengan yang akan datang. Okey. So kalau you buka, okay, if you try to apa dia panggil apa? Bukakan pecahan tu kan. Try to apa nama ni? Apa yang dia panggil lah, try to you darabkan setiap lah. So for example like this you buat macam F0 H2 tambah F1 H bagi 2 bla 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 tambah until H Fn divided by 2 So and then you try to simplify again, and then we found that for the earliest one and the ending one, okay, so dia akan tetap yang sama lah. So ni dia tak akan tambah kat mana-mana lah, sama dengan yang hujung. So that's why dia punya formula dia sama. Dia tak ada darab dua lah. So yang lain akan ada darab dua. So you darab dua, you summation yang lain. Okay, so this is the final equation. Okay, the final equation. So you can enter the final equation to the calculator. Okay, I think this one calculator dia gunakan dia bukan masukkan semua, dia guna table if I'm not mistaken. Okay, so nanti kita tengok cara dia gunakan dekat calculator macam mana. Okay, I think dia gunakan table 9, dia masuk nilai, and then dia akan dapat lah. So berapa fx, berapa segments. So nanti dia akan dapat. So yang ini senang, this chapter is easy because you enter the equation to the calculator, and then you give how many segment, and then what is the interval lah between A and B. Okay, and then they will tabulate the data. So the data tu akan ada lah dalam table. Okay, dia akan tabulate lah the data. And then you take the data, you rewrite again, and then you just try to sum up lah. Okay, nanti saya akan ajar lah macam mana cara nak penulisan dia. Okay, so kita dah masuk example. So sebelum tu mana ni?